Okay, hopefully you had a nice Thanksgiving break and you're ready to be back and hopefully do very well on this next quiz. So, let's quickly go over this to make sure that you understand all these concepts. So, the first two are graphing. So, anytime I give you a graph, you can use a graphing calculator. So, the hardest part is making sure you type the rule into the calculator correctly. So, x raised to the third power, push away. So again, if you don't push away, then you're writing up where your exponent is, and it's not going to be the correct graph. So I have minus 3x squared minus 2. So we can see what the graph looks like, but the main thing is we need to be able to plot, and you should be able to plot at least 5 dots. So I want to position my table so that I can plot 5 dots. So starting with -1, I'm going to do -1, -6. There's a dot. 0, -2. There's another point on my graph. It looks like 1, -4. Then 2, -6. And finally, the last dot I have room to plot would be 3, down 2. Okay, now we're going to connect these dots, these 5 points, so that we show the idea of end behavior. We should know that this is odd, so we're going to have our graph pointing opposite directions. So let's connect the dots. It's going to increase. It's going uphill. It hits this peak, which we're going to call max in a couple seconds here. It changes directions. It goes downhill, hits this minimum, turns again, and then it goes up forever. Okay, so that's an okay look for this graph. You can see it looks similar. Okay, that's all I'm going to be expecting from you, a quick little sketch of the graph with at least 5 dots, guaranteed at least 5 dots. So here's what this means. These are turning points. This is where the graph changes directions. So you just need to name the points where it changes directions. If it's at a peak like this, it's a max. So for my max, I'm going to say 0, -2. Here it turns to, it's descending, then it goes uphill. Here is a minimum, it's a valley, and it looks like that's going to be 2, -6. Okay. Now, as far as increasing and decreasing, you must use X values. Your brain's going to want to use Y values. You need to force yourself to be looking at the X values, starting here on the left, negative infinity. So we can see, so my pencil, the pencil here is my Y values. This finger's right here is my X values. As I move left to right, I need you to see from negative infinity, as I move, my graph is going uphill until we get to an X value of 0. So I must say from negative infinity to 0. So that part, it's going uphill left to right. Then it goes downhill for a small portion, but then it starts to increase again. Please do not put -6. We're using the X value, this 2. So we're going to say from 2 to positive infinity. Okay, it's going uphill. The only section it's going downhill, decreasing, is from this point to this point. And again, so many students want to say from -2 to -6, but they're the Y values. I must use my X values. So all I'm going to say for the decreasing part, it's going downhill from when X is 0 to when X is 2. Okay, you must use X values. Okay, that's number one. Number two, we'll do the same thing. This time it's going to be a negative. So hopefully you realize negative and odd, it's going to have the opposite end behavior. It's going to rise on the left, go down on the right. So let's confirm that. X raised to the third, push away, plus 9x squared minus 24x plus 19. See the graph should be going, oh, look, somehow, again, how in the world did I miss that? I somehow hit a 3 instead of the plus sign. So again, can I say I did that on purpose? I purposely mistyped, and when I looked at the graph, I knew something was up. It did not follow what the end behavior should be. So now let's see if I did this correctly. And that looks like a much better example. So it's going up here on the left, it's going down on the right. I go to my table and I'm going to position my table. And the first point we can plot, it looks like 1, 3. And then 2, -1, 3, up 1, 4, 3, and what? 5, -1. And then all I need to do is connect these dots. We know it's rising on the left. It's going to go downhill. It'll hit this turning point. It'll change directions, go through this point, hit this turning point, change directions one last time, and go down forever. Okay. Not bad. That looks okay. So now we have a minimum. Again, that's a valley. It's where the graph changes directions. When it's a valley, it looks like it's going to be 2, -1. Okay, my max, this point right here, it looks like 4, 3. Okay, as far as the intervals, increasing, decreasing. This time we'll do the easy part first. It's only increasing from this point to this point. Everywhere else it's decreasing, but again, we have to use X values. So it's going from 2, not -1. I use this X value right here. I go from 2 to 4. Everywhere else in this graph, it is going downhill. So if I start on the left, that's -infinity. It's going downhill until I get to an X value of 2. And then it will go uphill from this short period from 2 to 4. It goes uphill, and then it goes downhill again from when X is 4 to forever. Do not be tempted to say -infinity. That would be Y values. Your Y's, your outcomes are getting smaller and smaller, but your X's are getting larger and larger as you move to the right. Okay, so again, a concept that you will see again if you take calculus at some point in your lives. So let's quickly do this section. This section shows all 4 cases of end behavior. So without actually graphing, we are going to just sketch the ends of these graphs. So all I'm concerned with is my largest exponent in this case is odd, and I have a positive number in front. Okay, I don't care what that number. It could be a 20 for all I care. All I care is it's positive and an odd degree. So that is down and up. Okay, just like our first problem that we did. That number 1 had an odd exponent and a positive leading coefficient. Okay, again, we're not concerned about the middle. For number 4, this is where I know it's going to be even. I need to tighten this. This is starting to fall. There we go. This is even, but then I have a negative number in front. So the leading coefficient is negative, which means it's a reflection. So it's going to go down, down. That's a simple parabola that opens down. Okay. But again, I don't care. That could be to the 20th power. As long as your largest exponent is even and negative, it's going to be going down, down. Here I have a case where it's going to be even, but then positive. So anytime it's even, it's going in the same direction. The fact that I have a positive, it's a 1, but it's positive leading coefficient, I know it points up in both directions. Again, I don't care about the turning points. I don't care about the middle part. And the last case, the only other possible scenario is if it's odd. So again, my largest exponent, just be careful. It may not be in standard form. Okay, you still need to search for the largest exponent, but in this case, I have it first. It's my degree of 3, which is odd, but then I have a leading coefficient that is negative. So it's just the reverse of this. So it's going to go up on the left, down on the right, just like our number 2 did. Okay, so that's what I need you to understand. Odd and negative, it has to be this end behavior. Okay, just like a line going downhill with a negative slope, that's what you're looking for. Okay, so there's page 1. The next page is just about something you really did in Algebra 1. So this is just about simplifying. If you want a box, you certainly can make a box when you're multiplying. So if you're finding the product of a binomial times a trinomial, you can make a box, or you can simply do this. So I'll show you the distributive method. So I'm going to distribute the 4x. So I'm going to have a 24x cubed. I'm going to have a negative 20x squared. And I'm going to have a minus 20x. Hopefully I don't make a mistake here. Now I need to come around and distribute the negative 3. So, and I'm going to line up my like terms right away. So this is why I actually prefer this method over a box, because when you do the box, your terms aren't going to be lined up. But it's your choice, whatever you feel works best for you. So negative 3 times 6 is negative 18x squared. I'm going to have a positive 15x, and I'm going to have a plus 15. I can combine like terms, and as soon as I do that, I'm going to be finished, and it's going to be in standard form. So my largest exponent is my x cubed. This will be 38x squared. This will be a minus 5x, and finally a plus 15. There's the product. Okay. This next one is just the sum, so you're adding, and the parentheses means nothing. Okay. Guess they're showing I have a trinomial plus a trinomial, but really the parentheses are doing nothing. So I do want to start with my largest exponent, which is x to the 4th. I don't see any other terms with x to the 4th, so I'm just going to simply write 6x to the 4th. I'm going to put that first. Once I take care of it, you can cross it out. Then the next one would be cubes. It looks like I have 2 terms with an x cubed, and when I have like terms, I just look at the coefficients. Negative 5 plus 4 is going to be a negative 1, and I'm just going to say negative x cubed. You could put a 1 if you want. It's up to you. This is now gone. I look at my squareds. I have 7 of them. Take away 3. That's going to be 4x squared. And then the last thing I have, the only thing left, is a plus 4x. And there I am done. Okay. The next 2 you can check on a calculator. So I have no problem you checking on a calculator. I'll show without a calculator, but then or actually for number 10, I'll just do on a calculator just so you can remember where the I is on your calculator. So since we're subtracting a quantity, I'm going to get rid of the second set of parentheses by distributing a negative. Okay, so once I do that, we're going to have a negative 4. That's my numbers. Put that first, followed by the imaginary part. And if you do this on a calculator automatically puts it in standard form. So let's quickly review where we do this on a calculator. I am going to type in, I guess I should show the bottom part of my calculator. So there it is. I'm going to type in parentheses, negative 1, make sure it's negative 1 and not minus 1, plus 7 second period. That's where the I is. Right there. It's real hard to see, but that is a blue I. That's my key for the imaginary part. And then I have another set of parentheses for 2 plus 5 second period. Close the parentheses, and the calculator will automatically put this in standard form. Okay. Now, if you want to do this without a calculator, let me just quickly tell you, you have to distribute or do FOIL. So if you think of FOIL, you're going to have a negative 2, and then that's my first. My outers is going to result in a negative 5i. Inside, I'm going to have a 14i. And then finally, I'm going to have a 35i squared. You have to remember that an I squared is negative 1. So when I see this, I know it's a negative 35. And this negative 2 and this negative 35, that's where we got the negative 37. And when you combine the imaginary parts, a negative 5i plus 14i. That's where we get the 9i. Okay, finished. Should be easy points. Don't get those wrong. Now, number 11, I am asking for the quotient and I must use long division. You say, why must I use long division? Why can't I do synthetic? There's a 3 in front of the x. Okay, so synthetic will work if it's x plus a number or x minus a number. Here, though, we are forced to write 3x minus 10 on the outside. The good news is this is only a trinomial, and it starts with a 30x squared minus 118x plus 56. So the process that we must use for long division, look at that 3x, think to yourself, 3 into 30. It will divide evenly, so if it doesn't, you made a mistake. So 3 into 30 is a 10. And then x into x squared is just an x. So we will just simply have a 10x up top. And now what we figure out to be up top needs to then be multiplied by what's on the outside, and then things will be lined up. So 10x times 3, we must have a 30x squared. Okay, has to be. But then negative 10 times 10x or 10x times negative 10 is going to result in a negative 100x. Notice how everything's lined up. Draw your line, and I'm going to take my red pen and I'm going to change these to its opposite. That's how we subtract that whole quantity. That is going to be critical that you don't forget that step. The x squareds are gone. This results into a negative 18x, and I'm going to bring down the 56. And the good news is I get to start this process over again, and you'll know you did it correctly because 3 will fit into negative 18. Negative 18 divided by 3 is negative 6. You don't need any x's. The x's would cancel out. So then just like last time, what's up top times what's outside, and line up everything. Negative 6 times negative 6 times 3x is negative 18x. And then this would become a positive 60. Okay. I then change everything to its opposite. So I'll do that in red so you can see I have that. And it looks like the remainder is going to be a negative 4. So I'm going to write my remainder. Since it's negative, I'm going to do a minus sign. I'm going to put a positive 4 over 3x minus 10. Now, if you make this a plus, you can then make the remainder negative 4. Either way, you're fine. That is the quotient. Okay? Now, the next one, we're still dividing, but this time we can use the synthetic division process. So let's practice that. The key to synthetic division, what makes that 0? What makes your divisor 0? So in this case, it's a negative 7. I'm going to put a negative 7 on the outside of my box. I'm going to put all these coefficients inside my box. And since it's cubed, I need 4 numbers. And the good news is I have all 4 numbers. There is a 1 here. We start with a 1, then I see a negative 2, a negative 55, and finally a 65. So I bring down the 1. That's how you always start. Bring down whatever that leading coefficient is. That gets us started. I multiply. Negative 7 times 1 is negative 7. I add. Then I multiply. I'm going to get a positive 63. This is going to be an 8. And then this is going to be a negative 56. And it looks like my remainder is 9. Okay, and again, don't mess up those calculations. If you needed to, I guess you could use a calculator to do some simple calculations, but it is critical that you don't get those numbers wrong. Okay, so now we can't stop here. We have to take these numbers and write the quotient. Okay, so this one really is x squared. It's 1 less than what this degree is. So my quotient is x squared minus 9x plus 8. 8 is my constant, and 9 over the divisor. My remainder goes over the divisor. Okay, finished with page 2, and we're at the 20-minute mark. You won't have as many problems on your quiz that we're practicing here. Okay, but I want you to be able to make sense of all these. We have another problem that we can use the synthetic division process, but be careful. Notice I have x to the fourth. I need 5 numbers. I only have 1, 2, 3, 4. So if you don't catch this, you're going to be messed up right away. So it is your job to make sure you're not missing anything. And in this case, I'm missing x cubed. So I need to put a 0 in its place. So this time I put a positive 8 on the outside, and I have 1, 0, negative 68, a 42, and a negative 80. Okay? I bring down the 1. I multiply. Oh, see there. That's what students do. My brain was one step ahead. I said I was going to bring down the 1, and I quickly multiplied in my head. Again, I'm going to say I did that on purpose because, again, that's a common mistake that students do. Their brain's a step ahead. So we have to slow things down, bring down that 1, now multiply, add, multiply, add, multiply, add. We get a 10. Hey, look at this. We get a remainder of 0. It's always nice to have a remainder of 0. And so here's our quotient. It's x cubed. So 1x cubed plus 8x squared minus 4x plus 10. And then the remainder, 0 over the divisor, I don't even need to worry about since the remainder is 0. Okay? So number 14, this is guaranteed to be on your quiz, guaranteed. Please don't write an answer with just 2 terms. When you square a binomial, you will get a trinomial, okay? So there's something called square double square. If you can handle this, then you can just write down the answer right away. If not, I want to see the work, okay? So I'm going to show you square double square first, and then I'll show you how you can do this without, where you would need to show the work. So let's quickly square double square this. So I'm going to have to take 3x times 3x. It's going to be 9x squared. The middle part, though, you can do the shortcut. If you take what's inside, you multiply it, but then you double it. So when I multiply, I get negative 24, but I'm going to double it, and I'm going to get negative 48x. And then I'm going to square the negative 8. Anytime you square, we're going to get a positive. So negative 8 times negative 8 is a positive 64. If you could follow that, you can do that on your quiz. If you say, Mr. I don't understand where the negative 48x comes from, then please write it out. Okay, so please take the time and do FOIL. Hey, there's my 9x squared. Outside, I get a negative 24x. Inside, I'm going to get a negative 24x. Together, that's where that negative 48x comes from. Okay, and then finally, a negative 8 times negative 8 is a positive 64. So again, you can show the work, or you can just simply do square double square in your head. I'm fine with that. Now, for cubing a binomial, yes, you could do cube, triple cube, but it's a lot more involved. So here's what I'm going to suggest. You break this up, and I'm going to end up taking, because really it's self times itself times itself. I'm going to quickly square double square this. Okay, so I have 2x minus 5 times this times itself. Well, I'm going to quickly figure out that trinomial. It's going to end up being 4x squared minus 20x. You say, where did the minus 20x come from? I get negative 10x when I multiply this times this, but then I double it because my outers and inners are each going to be a negative 10x. Together is a negative 20x. And then I get a 25. And then we get to practice a binomial times a trinomial, and as soon as we clean this up, we're done. So this is a more difficult problem, but it's something that every student is capable of doing. So 2x times 4x squared is going to be an 8x cubed. This is going to be a minus 40x squared, and it's going to be a 50x. Now I'm ready to come around and distribute the negative 5. I'm going to line up my like terms. It looks like it's going to be negative 20x squared. This is going to be 100x, and then this is going to be a minus 125. Again, if you need a calculator, use a calculator. Don't make a silly calculation mistake on your quiz. So all I'm doing is simplifying, combining my like terms, and there's my answer. Okay, so again, you can practice and you can use Photomath to check your answer. You can come up with your own problem. Take any little binomial, make it up 3x minus 7 cubed, and see if you can figure out the correct answer. Okay, here is a review of factoring. So I don't want us to forget how to factor. These are slightly more difficult problems, but notice it's not an equation. So we're not using factoring to solve. We're just rewriting this as a multiplication problem. So for this problem, it's more difficult because there's a 5 in front. So that's where we use that AC method. So make my little x. 5x squared times 12 is a 60x squared. I'm going to want to come up with a combination of two numbers that when I multiply them together gives you the 60x squared, but then adds up to a 32. Okay, so it came into my head right away. I know it's a 30x and a 2x. That's what satisfies that diamond question. So what we're going to simply do is replace that 32. So the 5x squared stays 5x squared. I have 30x plus a 2x plus 12. I split it down the middle. I look at these two terms and I think, hey, what's in common? Well, the 5x can be factored out. I'm going to have an x plus 6 inside. If we did this correctly, I better have an x plus 6 on this side, and I will if I factor out a 2. So what's in common on this side is a 2, and now we have our answers. We take the pieces on the outside. That makes up one of your factors. What's in parentheses will be the other, and there's your answer. Okay, and if you had these different, you would still get the same answer. So if you wrote the 2x first, then the 30x, you're still correct. Okay, so this is the only combination of factors that when you multiply, we get back to my original problem. Okay, so another one for 17. There is my diamond. I get a negative 24x squared, and I get a negative 5x. So again, my brain is already working, thinking of ways of getting negative 24, 1 times 24, 2 times 12. One's going to be negative, one's going to be positive, but I know a negative 8x and a 3x will satisfy that. Okay, so if we did it correctly, I should be able to replace that negative 5x with what we found for a diamond. So in this case, a minus 8x and a plus 3x. And then don't change the problem. This stays minus 4. I split it down the middle here. They're both even, so I know I can factor out a 2x. 3x minus 4 inside. Over here, I must see that. So really, you just need to put a 1 on the outside. You have to put something. So don't just leave it blank. It's not a 0. It's just a 1, which means a 2x plus 1 and a 3x minus 4 are my factors. And it's always a good idea, especially on a quiz, to take 2 seconds and check. 2x times 3x. Hey, there's the 6x squared I need. Outside, I get a negative 8x. Inside, I get the 3x. Together, of course, is going to add up to that middle term. And a positive 1 times negative 3 is negative 4. It checks by FOIL. Okay, we're almost done. We're almost at the 30-minute mark, but we would still have 10 minutes left if this was an actual quiz. But again, my actual quiz is not near this long. So we have a problem where we're told to solve by square root. Again, we could use the quadratic formula, but it's actually so much easier since we only have an x squared term to simply add a 6. When I add a 6, I get an 80. When I divide by 2, I get 40. To figure out what x is, I take the square root. So I'm going to take my pen just to show that. And then you need to realize I want this simplified answer, and I want both answers. So don't forget the plus or minus. So within 40, I am hoping you realize right away 40 is 4 times 10. And the reason you want to break it up as 4 times 10, 4 is a perfect square. You always want to find the largest perfect square that's a factor of the number. So Square root of 4 becomes a 2. The 10 stays a radical. And now it's in simplest radical form. Okay? The next one, just as easy. This time I have to get rid of the 5, so I'm going to subtract 5. When I subtract 5, I'm going to use a calculator because I'm going to have to divide by -9. So we're going to have 491 minus 5. That's going to be a 486, but then I'm going to divide right away by -9. And when we do that, we're going to get a -54. We're not going to panic. We are now allowed to take the square root of negative numbers. It just means our answers are going to be imaginary. So we're going to have two imaginary answers for solutions for this equation. X equals plus or minus. And just like last time, I'll put the I on the outside here, but then I'll put it in the right spot for my final answer. You need to know what times what is 54, where I have a perfect square. So you would have to go through perfect squares. 16 doesn't fit in, but the fact is 9 does. So the fact is 9 times 6 is 54. And the reason I want to break it down that way, the square root of 9 is a 3. So I'm going to write my 3, then I'm going to write this I. So I like to see the 3I and then root 6. That is in simplest radical form. So just think about this. It's pretty easy to get to that step. So subtract your 5, divide. The square root method is a lot easier, but you could use the quadratic formula. You would still need to get a 0 on one side if you're going to use the quadratic formula. But I am telling you to solve by taking the square root. Okay, last page, and this page won't take us long. I review the quadratic formula. So let's quickly review. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, the first one's already, actually both of these are in standard form. So it's a simple matter of picking out your a. A is the number in front of your square term. Remember, you will never substitute a variable into the quadratic form. It has to be a number, has to be the coefficient. So in this case, a is 1, b is 1, c is 3. So I would always write that. So make sure you don't skip that step. And now it's really easy to take the opposite of b plus or minus b squared. Since it's a positive, I don't need to worry about parentheses. 1 squared is just 1. Minus 4 times my a times my c. That should be a simple calculation. And 2 times 1. So then I'm just going to ask that you clean this up. I always want to know the discriminant. Okay, so now you can probably do this without a calculator. This one, the numbers are really easy to deal with, but I'm just going to type in exactly what I see. I have 1 squared minus 4 times 1 times 3. I get negative 11, which I'll write it this way, but I want you to realize it is an imaginary, in fact, two imaginary solutions. The discriminant is negative 11, which means we will have, put the I on the outside of my radical, make the negative 11 a positive, and there is my final simplified answer. Okay? 21 should be just as easy. Okay, the quadratic formula should be very easy. Again, I was nice enough to give you 0. So A is a 5, B is negative 5, and finally C is a negative 2. X equals 5 plus or minus the square root. Now make sure you put negative 5 in parentheses. Without that parentheses, you're going to get the wrong answer. So calculator must have that. I must get a 25. Negative 5 times negative 5 is 25. Without parentheses, calculator thinks it's negative 25. So just be aware, heed my warning, and then we get all over 2 times 5. 2a. So let's clean this up, see what we get. I need to know the discriminant. So I'm going to simply ask the calculator negative 5 squared, or simply put in 25. So if you want to do that calculation in your head, it's better to do it in your head than type it in your calculator incorrectly. So then the rest of this is going to be minus 4 times my 5 times negative 2. And I get a 65. And since there are no perfect squares in 65, I'm just going to leave it in that form. I'm not concerned about the decimal answer. That would be the two answers. 5 plus root 65, then all over 10. And then if you do the minus, you'll get another answer with 5 minus the square root of 65. You'd have to hit enter, then divide by 10 if you went to decimals. Okay, last problem. Actually, almost the last, second to last. We are told to type a rule into our calculator. So we're going to hopefully make sense of this problem. We're told that we're dealing with revenue. So grocery stores annual revenue after T years. So the T is our X basically, and our outcome, the Y, which when we're looking at our table, we're going to know that the Y values stand for millions of dollars. Okay, so let's carefully type. That's the hardest part of this problem, is to make sure how many zeros? 1, 2, 3 zeros. So you don't need the first zero. It's point, then 1, 2, 3 zeros. Then I see a 1. Then I have parentheses. I see negative x raised to the fourth, push away, plus 12x. What is that? Cubed. I need to make sure I'm actually typing this in correctly. Minus 77 x squared. We do have a square button. And then plus 600x. And then finally plus 13650. Close the parentheses. So there's my revenue. And I'm going to go to my table. And I am going to hopefully understand these are years. Okay, so when we first started, hey, this is how much money we had. And so they want to know, what was the store's revenue in year 1? So I look when X is 1, and we're going to see it was 1.4, and I'll round to the 100. So I tell you what, enter the calculator. So what is the store? So it's about $1.42 million. Okay. In what year or years was the revenue 1.5? So I can clearly see in year 3. And then let's see if we have another one. Maybe it comes back around. Yes, it does. Look at that. In year 9. Okay, so we just have to scroll, because remember, we're not just dealing with a parabola now. So this has really up to three turning points, this graph. So this is going to be year 9 again. After how many years would you expect this store to go out of business? Well, you're going to go out of business when you are no longer making money. Okay, so in year 12, hey, we're under $1 million now. I would be somewhat concerned about my business. And it keeps on getting worse, so that between years in 14 and 15, it's actually going to end up costing us money to stay in business. So about after how many years would you expect? So I would say between 14 and 15 is when it's time to close up shop, go retire on a beach somewhere. Last problem. I want you to use synthetic division. Now, you could always check by direct substitution. If I replace that x with negative 3, I should get the same answer as my remainder. So for synthetic division, or excuse me, synthetic substitution, I don't change this to its opposite. My input is negative 3. So I want to replace the x with negative 3. It stays in negative 3. That's the hardest part. People confuse this with long division, where we do, if we're dividing by x plus something, then we put a negative number. If it's x minus, it becomes a positive number. Here, whatever the number I tell you, it goes on the outside. And let's line up the coefficients. I should have 4 of them. Negative 2, negative 5, 2, negative 8. We go through this process. I bring down the negative 2. I multiply. I get a positive 6. I add, I get a 1. I multiply, I get a -3. When I add, I get a -1. When I multiply, I get a 3. And when I add for the last time, I get my answer. And I promise you, in fact, I will end this video. We're at the 40-minute mark. We would still have 2 minutes if this was an actual quiz. And I did lots of talking during this video. But I will end by taking this and do a direct substitution. So wherever I see an x, I'm going to substitute a -3. So I'm going to first of all raise it to the third power. Then I'm going to have -5 parentheses -3 squared. And then plus 2 times -3, and finally -8. And if we did this correctly, when I hit enter, it should be -5, just like I have here as my remainder. Hey, I feel good. We know we did this problem correctly because my outcome, so the answer f of -3 equals -5. Okay, that's just function notation. It's an ordered pair, input, output. Okay. That is everything. It's actually more than what you're going to need to know for your quiz, but please make sure and let me know if you want to have extra practice problems. We have some practice worksheets on the synthetic division and long division problems. We have some extra work that I can provide with adding, subtracting, and multiplying polynomials. Just make sure you reach out. Okay, so technically 20 seconds left in the period. We're almost at the 42-minute mark. And I'm going to hit stop. But thank you. Reach out to me when we return from Thanksgiving break. Take care.